So we are almost there with answering this question, and the thing that we do need to consider are the moments of this car, specifically acting around A, which is here, when our free body diagram is here, because we have an object in static equilibrium. So let's pick up where we left off in B. So the sum of moments about A, and we've chosen A just because it's easier to take moments around. We have distances relative to A, and so it just makes sense to go from A. We know that, of course, these are going to be equal to 0. We'll put that in at the end, though. So let's start taking moments. We know that our reaction force B is going to be 1.75 plus another 1 meter, which puts us at 2.75. So let's write that as 2.75 RB. Let's consider some of the other forces that we have that might contribute to this moment. Well, let's consider this weight force of 5,000 G. What component is that we need to consider? Well, we have the vertical component relative to our XY scheme. However, this is acting opposite to our chosen direction. So again, just for clarity, actually, in this case, let's say that our chosen direction for the reaction forces is counterclockwise. So that puts our moments at negative 1.75, because that's where the center of mass is along here. 1.75 times 5,000 G. Let's put that in brackets for clarity. Let's add to that 5,000 G. Sorry, I forgot something key actually here. That's 5,000 G cos 30. Excuse me. And then we're going to add to that 0.6 times 5,000 G sine of 30. And you might ask, where does this come from? Well, if we have a look at the question, we've been told, and we can have a look at the diagram, that we have the center of mass here sitting at point G, 0.6 meters above the inclined road surface. So what that means is, if we consider how the forces are acting at this point G, let's move to a pen rather, around this point G, yes, we have this vertical force, but because also equally we have a force that is some distance away, i.e. this 0.6 meters, we have a force that is acting perpendicular to some distance, which means that we do get some moment generated. Now, if this car was flush with the ground and we just considered this car as a block on the ground, then because of that, like a point mass basically, because of that, we wouldn't consider this distance. We would just consider the, in this case, vertical part of the weight. But because we have this distance, let's use that. It's not always the case that we use what's been given to us, but in this case, let's use it. And we consider that we take that weight and we multiply it by 0.6, and it's acting, I've said plus, in this case actually it should be minus. And then, yeah, similarly, the horizontal part, that's also going to be acting contrary to the direction of moments here. Let's just double check that everything works there. Yes, it does in fact work. Like so. And then let's consider also the tension, so minus brackets T cos 20 times by 0.3. Let's consult what we have here. Again, cos 20, as we have this component here acting at some distance away, which is going to induce some torque, some moment. And to that we're going to add brackets T sine 20 times 3.25, which is our total distance of this structure here. I think actually this should be a plus. So through a bit of rearranging, we can see that we can get, and again, actually just before we move on, let's set this equal to 0, because we're in static equilibrium. Through some rearranging, we can isolate RB. And note that we don't have RA here. So once we've found RB, which I will leave to you to plug numbers in and rearrange accordingly and appropriately, you think, okay, well, we've got RB. Let's refer to the question. Have we answered it? We're being asked to find the reaction forces, plural, and the tension T in the cable. Well, we found tension T pretty quickly, but we haven't found the reaction forces, plural. We found the reaction force RB, so which leaves RA to be found. But we found RA at plus RB here. So bringing that forward, we can then say, therefore, RA is equal to whatever this is here, take away RB. And then from there, again, I'll leave that to you to figure out what that is, not forgetting our units of either newtons or kilonewtons. And there we go. That's answered this question 4 here.